Welcome back, fellow scrubs. This is Mark D. Wiz, the project leader for the Retro Mansion game, yet to be titled, but it's a spooky platformer. That best describes it. Let me get the feed going. Yeah, spooky retro platform game. Kids run around the mansion and get scared and hit things, probably with baseball bats, I assume. Ricky looks like he'd have a baseball bat, right? Right? Looks like he'd use one. Anyway, so where we were last time was, I believe, making the heads not go into the walls, for lack of a better description. And so you can see that that's actually working fairly well. Still a little bit to be done there. But their heads will not protrude into walls. And I think, what did we do here to show this? Let me copy this guy here, and that'll show too. He's always going to get blocked right here, and the rays kind of show you where he's headed. And right now he can only go up predetermined slopes. I guess this one's not steep enough to keep him off of it, so he can go through that one, but he can't go up that one. And that will be adjusted and changed as we go through. But you see the arrows kind of giving an idea of where those rays are casting out. And the yellow is sort of a extended view, but the blue, and it might be hard to see because it's very small, but if we step it and pause it, the blue is where you were to now where you've ended up, and it does that in 2 steps. That's why there's 2 arrows here. So the first step from here to here, and then there. Every frame's got multiple steps to it, and that's more of an accuracy thing than anything. And then it will eventually hit the corner here, and should stop. Oh, you know why? This one's not going to stop at the corner, because this is considered a ceiling. So it will stop at the head point. Yeah, it'll stop at the head. So if it's steep enough, it gets considered a ceiling, and there's a little leniency there. But if it's not considered that, then jump them over here. They can see it, it's here. Then here you'll see he hits the corner. And boom, and he hit the corner, and he can't move anymore. So see, he's attempting to move this amount, but he can't because he hits the edge here. And that works, and that's cool. And that's pretty much where we are at this point. I think what I'm going to try to do today is to do those lines, but down for the bottom portion. And there's a couple reasons for that. Number one, to detect like obstacles and stuff in the way, but they will need those for other cases as well. And I think, like, is it over here? Yeah, because he can get inside here. And if you have a corner, a bottom right corner ray, so this one's just the center one, but that one doesn't think about walls and such. But since this is not considered walkable, because he can't walk on it, you can see that he will not progress. That should be considered a wall, and so this thing should stop him from reaching it. But instead it doesn't yet, because there's no such ray there. Here, they're all kind of overlapped here, but you can see that there's more than one going on here. Excuse me. So there's a couple things to consider here, and I'll demonstrate it on my favorite paint thing here. pick a good color. That look good? That looks good. Nice and bright. So if we're here, one of the problems with this, say this is the ground here. This is ground under here. If you're shooting a ray, it will be like, I found ground immediately. So like, what do I do, Chief? And so that's something to consider, where we have to smartly ignore this kind of thing. But what if... Oh, that's funny. It's not the right gray. There we go. What if we have this situation? We want to go from here and he's going to shoot this way, right? We want to make sure that this doesn't cause any problems because we're inside that floor. But we need to stop here. We're not allowed to go farther because this is still a wall. And to make this a little more clear, let's say that, you know, this shape, this is 1, and this is the floor that we're already on here. So they're sort of intersecting shapes. You know, this is the crossover pattern. Clean that up. And so you don't want to detect this, but you do want to detect this. And that has to be considered a wall. So that when you, I guess when you walk that way, you'll probably, this probably would actually end up here, but so you would only be able to walk up to this point, because at that point, you know, your edge here would have hit. Or if I want to follow the original diagram, I guess you would say that our edge hit here, and we cannot move farther than this in that direction. So that's one thing to be cognizant about. You know, the big fancy word, cognizant? I don't know, whatever. You get the idea. You have to be aware of that. So how do we do that, though? How do we know that we've actually left this in our intentionality, and then we need to also check the fact? So one way that I was thinking of, and I may or may not have mentioned this last time, it's been a couple weeks. If you shoot a ray this way, you can never detect if you've left here. You don't get a hit on leaving. There's no exit wounds. If you think of it as like a bullet, you only get entrance wounds. So there's the entrance wound here from shooting into it. But you don't get an exit wound here. You don't get that by shooting out from it. You get one hit, and that's the closest possible hit that you can have, which is actually where you start. So it'll say that we got a hit on this guy here at a distance of 0 because we fired the gun, or the ray in this case. If you want to pretend it's a gun to make it more understandable, you fired the gun right here. It's like you held it right up to the guy and you shot him right here. And it's like, well, you hit here. We don't really care about it came out here. We only care about it hit here. So I'm thinking, what if you do this in reverse? Say, okay, we're gonna shoot this far, right? But then let's find out where this is gonna end up in here, and then we're gonna shoot backwards here. Now we won't get this exit wound on the second one, but we will get an entrance wound on the thing that we left. So the logic here is that if we fire our ray backwards, and we actually hit the thing that we started. So I guess first things first, if you fire the ray and you detect that you're inside something at a distance of 0, you check where the ray ended up in its totality, and then shoot backwards. And if you actually find an entrance wound for this guy here, that means you know then that you have left that collider and you have were able to shoot back and detect it again. So you know that you left this guy and you entered the second guy. Or maybe you didn't find anything after it. But at the very least, you know that there are potentially valid results from this point onward. Because you know where it left. And you can tell where this is. Because it's just a reverse raycast from the other side. So you can find out, okay, anything past this distance now, going this way with the original ray, it validates all the results that are beyond that. Now this could get a little tricky, but I think it's a fairly solid concept. I haven't thought of too many flaws at this point for it. So I think we'll try to do this and see what happens. If it works, cool. If it doesn't, we'll figure something else out. It's a lot of trial and error in this kind of thing anyway, so I'm not too intimidated by that aspect of it. We'll just keep doing it till we get it right. And alright. So we have to do two things at this point. We have to actually fire a ray from the bottom right and consider that whatever it hits to be, how do I want to say? Whatever it hits has to be valid, and it has to act on that as if it is valid. And then we have to create the exception for when we fire backwards and do that check if we need to. So we'll do it that way in 2 steps. I think that would be the best way to implement this kind of thing. So here's the wall check. Here's the top right corner ray, shooting the top right corner ray, and then we had to shoot the top left corner ray, and now that is quite simply what we already have here. That's these two. This is the top right and the top left, and they're both valid in this case. So now we need to do basically the same thing, just for the bottom right and the bottom left. And for now, we'll do the bottom right only, since I think that makes the most sense. We'll start with one and then work our way. Now the good thing about the bottom right one and the top left and all that, they're all the same length. So we should be having a lot of, how do I want to put this? A lot of the code should be the same, and we should be getting a lot of similarly expected results out of them and how to handle them. So let's take a look at our World Collider. So these are the points. We want the bottom right, right? So that's 0.1, right? Yeah, 0.1. Up, left, up, right. Yeah, they're just reversed. Okay. So we want 0.1. We've got the walk direction, we've got the move distance. Those are all the same. As you can see even here. Oh, because we changed code, it recompiled. It won't let me look at it. But, I guess it's recompiled now, so here, you see they're all the same length, because it's all moving the same distance. So here, doesn't look like this one did anything yet. Yeah, because it's acting on top right results, so. Alright, we'll fix that up. So it wants a 1 there. Got array ID. So this, instead of top right results, we want bottom left or bottom right results. And there's a few of those to sort out here. Okay. Or collision with ourself. Accept surfaces that are walls and not floors or ceilings. Hey! EX Wild Wolf, thank you. That's a cool name, EX Wild Wolf. Is that a Terry Bogard reference? Sounds like one. So you get the floor line, you check if it's a surface or not. If it's a floor or a ceiling, then you don't bother. And then, let's see, is a wall. So you check if it's a wall. If it's a wall, cool, continue. So, let's see now. It is? Yeah, figured. Full name, I like it. So we do get the surface here. I don't know what it will do if it shoots a ray into the actual corner. Like if it actually shoots it into like right starting here. I'm not sure what it. Oh, got a bounce. All right, cool. See you later. Thanks for the follow. I don't know what this will think it is, if it thinks it's a wall or not. It's gonna try to get a floor line, but it might not actually be able to get one of those. Let's see. Okay, get floor line. Yeah, if it's not a surface. Oh, if it doesn't get a line, then it continues. We might have to put the code, the emission code, here then to check, see if we started inside of something. And yeah, so probably what we're gonna do, yeah, let's do this. Started inside floor. I'm gonna say it's false. And yeah, so if we don't know yet, we're going to check. Should we do another check? Cool. Check for started inside floor. We'll say true for. Yeah, actually, we may not need this one. Let me do this. So if we're gonna check for that, then if the hit distance is equal to 0. We only want to do this reverse check here if we hit something immediately right out of the gate. So if this thing is 0, we have a 0 distance result. Otherwise, if we're beyond the 0 mark, then this just has to be false, because we don't care at that point. Okay, we have a 0 distance result. So I think we need to check if this is the thing we're standing on. So line ref, current floor line ref dot collider equals, yeah, and then we check the collider of this. Okay. The result was what we were standing on. So let's see, now we need to check in reverse, see if we exited this for an input. There. Yeah. Now we need to shoot a ray backwards. So we need to do this little reverse thing. And we need to do it right here too. Because if we don't leave it, if we don't leave the collider, all results are invalid and we should skip the checks in this. If the reverse But if we detect that we left Collider, all results past that distance, past that leaving distance, are valid. I think that sums it up pretty handily. So let's take a look. Or, well, so let's think about this here. We should make an encapsulated reusable thing for this, but yeah, let's do that. We're gonna say check for collider exit. What we need to send it is the collider ray. Let's do this one. Collider to the collider. We need a ray direction. So direction to ray length, and then we can. Oh yeah, and ray firing position. So vector to ray origin, saying where it starts, what direction it is, and how far it was shot out. And then using these, we can figure out where the ray ended up and then fire it backwards. So check for collider ray exit, and then this is going to have some kind of multi-structure return. So we'll need more than one piece of data here. So let's do this now. Public, let's say void for now, but it is going to be something different. We need to create a structure for this. So public class ray exit check result. Let's see. What do we want? Private bool is valid, I guess. Let's see, valid or has exit point. Yeah, let's say has exit point. And by default, it's false. And so public bool has exit point. Get return. This way we can't modify this after the fact. Only the probably want to use an auto propagate. Only on creation will we be able to change that. So we'll do we'll add exit point, and then yeah, move that way. But well, hold on, we could make this a little more efficient. Exit point. Float valid distance start. Flubbed it away. So we can do this two ways. One, if we create it without any parameters, it's kind of admitting that we don't have anything. And if we do create it with parameters, then it's basically like, hey, here's the data. So we have something here. So we can do this the same way. That way we can't actually change these things. Wait, could we do private set? We could do private set, right? That's what this is what wants me to do. Get. We'll get public get. Private set. I think, yeah, it's just get and oh, I think that's what we want. No, I need this. Yes. All right, that'll go with what we want. I think we'll be okay with that. They can do it at once on the inside. But things from the outside won't be able to change it, and that's important because that's data integrity. Okay, so 0 and then 0. Yes. Yeah, this will work. This is that exit point. Exit point. And this denotes that it's this one down here, the one that belongs to this object. So this get a little hairy if you use the same things, but they're always. As much as I like the music, volume is 7, while your voice is a 3 or 4. What? Well, that I didn't expect. All right, hold on. Alright, let me know if that's better. That's weird, I checked it beforehand. I don't think I changed anything after the fact, but let me know if this is better. Could be track dependent too, if we have a high track there. But yeah, let me know if that's cool. This should be okay. And so if we detect that this is not valid, then we'll just create one without a parameter. And if we do create one with parameters, then ratio is better, but your voice is, well, okay, you know what? I think I may know what happened. Hold on. I think my mic might have been doing that thing where it gets like really soft again. So let me know if that fixed it. And if so, then I'll push the audio back up because it's probably overpowering the music greatly now. If that was the case. But yeah, let me know if that's right. I don't know why it does that. It's a real pain. Voices, yeah, alright, I figured that was it. Okay, bump the music up a little bit. Let me know if that's alright. I figured that was the thing. I don't know why the mic does that. That's the only thing plugged into the soundboard that does that kind of thing. I don't know if it's that input or what's going on. Because I think it was doing on another input too. So either the mic's going bad or something's wrong. It's starting to piss me off because this mic ain't cheap. Okay. Alright, so the only thing we need left is the ability to easily check it, and that's what this is for. Oop. Oh, let's copy that and head back here. This will check if it is an actual thing or not. If it is not an actual thing, then it's toast. And also, if it has an exit point, then it's considered good. If it doesn't have an exit point, you can still bump the music? Okay. I shouldn't have screwed with the volume before I checked the mic. I should have known it was the mic that was screwing up. Alright, let me know if that's good. It's probably about where I had it. Let's see. I think so. And then if it has an exit point, then it's also valid. So it has to both exist, obviously, and have an exit point. And that's an easy way that we can check it as a bool. I love doing this now. I never want to not do that. Wow, we're that far in the playlist already? Oh man, time's flying already. Yeah. I like this one, I'm turning it up. I was wondering why that didn't like it. This should be a float, not a vector 2. Well, that's a different that's a different song. Oh, this needs to be multiplication. Also a funky song though, so it's all good. Alright, back to normal levels. There's no orange here? So I'll use red. That'll pop out a little bit, I guess. So... I really like this one. I think it's from Sonic CD, but I think it's an official remix, from what I gathered. Really nice. I like this one. Because the OST that I found had like 3 different versions of each song, like the original, and then like two or 3 different like remixes, but they're all in a certain style. So like each track has, I guess this one's called the G mix, and then there's another one that's like the C mix, and then I think the B mix. And so there's like a B mix for everything, and there's a C mix for everything, etc., etc. It's actually really neat. Like they gave somebody the reins to like remix the whole thing. It's very nice. Very good stuff. Very chill. I like most of the G ones. Some of the B and C's I didn't like. But yeah. That's my taste. Oh, and it's over already. I talked through most of it. In fact, let's just steal the code here. Oh yeah, we don't want to consider ourselves either. Just gonna say, hey, you know what? Instead of just results, I'm gonna hit results. It's always good to be a little more explicit. So if the collider we hit is equal to the collider that we want to check against, if the distance is equal to 0, we have not left the collider, since distance is 0. So we will return a blank result. So it will say that it has not left. Oh yeah, a new one of these. And that blank one, yeah, so has exit points false. And then else, meaning that the distance is greater than 0. Because you can't have negative distance on a raycast. It's always moving in one direction. It has that magnitude. You can't have negative distance there. Then we'll give it this. And so, no, you know what? We can just return as is. We need to give it those parameters though. So it wants an exit point, and it's certainly easy enough here. That's point. Now here's the thing. We want in inverse direction from the length. So we need the distance here has to be ray length minus the distance. Because we shot out this way, and so we want the distance, we want to know the distance in order of the original shoot that we did, so we can say, oh, everything past here is good, and everything behind that is bad, right? So you're shooting backwards, then your distance is going to be, like, say, I don't know, this is like 0.8, but here it's 0.1 or 0.2 going this way. But we want the 0.2, we don't want the 0.8, so we just got to do it in reverse. It's simple enough. You just take what your maximum length is and minus the distance from it. So in this case, our maximum is this, our hit is here. So our max minus the 0.8 or whatever, say it's, yeah, let's say this is 0.2, this is 0.8. So the 1.0 minus the 0.8 gives us the 0.2. Simple enough. Oop. So our full length minus what we actually hit. And that's it. And in fact, we can simplify this a little more. So if it's 0, then yeah, then we want to check if it's right or not. If this is greater than 0, then we're done. We don't care, because anything beyond 0. Wait, no, that's not true. That's not true. Hold on. Let me think about this. If the distance was 0, and I need to get rid of this. Okay. Trying to make it happy here. If the distance was 0, and that's our collider here. Get rid of that. Then we return it's bad. And then we don't worry about this here. If it's not 0, I guess we still have to do this. It might have been more efficient the other way. I think the other way was fine. Alright, jacked it all up here. Because we're only concerned with whether it's our collider or not. If it's a 0 result, yeah, because we only want to check our exit point. We're not checking anything else. I'm kind of getting my head of myself thinking there's other results that we have to worry about, but we don't. We only have to worry about our collider. And in that context, we actually don't even need to check this, because we're not going to act on anything else anyway. I don't need to check what our collider is. That's just a waste of time, because we're already checking that inherently here. Only if it's the collider that we're looking for. Specify that it's the 4 collider. Didn't find anything. Bunk. And that's the end of that. So that's our fallback result. Can't believe the thing's that far along already. Almost an hour in. Time's flying now. Yeah, so return ray origin. That's just where we started from, plus the direction and the length. That gives us where we're gonna end up when we shoot backwards. All that should be good. This actually shows the ray as a debug. So it's the return ray origin, the opposite direction, so minus direction, and the same length. I think this should be alright. This should be good. We only check to see if it's the 4 collider. I don't care about any other results. So if we do get a hit, and it's at distance 0, we know we have not left the collider. But we get a hit and a distance anywhere else, then we know it's good. We know we left it, and we can send back the exit point. And if we didn't find anything at all, for whatever reason, the fallback is nothing. We just don't do anything. And any other collider results we don't give a shit about. It's not in the purview of this check here. So, let's fill out this stuff here. With our current 4 collider. Our ray origin is this. Our ray direction is this. And our ray length was this. Okay, so var reverse or exit, we'll say exit point result. Okay, and then we can check if exit point result, and that means that we have a valid one, if that's true. If not, then we don't. So either way here, this is going to turn off. Don't have to check this again. Yeah, so if we get a result that's not 0, then we turn it off, because we only care if we fired the bottom right from inside something else. If that didn't happen, then we don't need to do this additional check. If we do get a distance of 0, and we do get a the same collider as the 4. Then again, we turn this off because we're not going to have to do this again. It's a one-time only. And then we go through all the BS to do it. Okay. Trying to think of how exactly we should do this. I wonder if I should do this in 2 loops or not. And then we'll check it again if it needs to. Okay, so bool. Bottom right array results are valid. You know what, actually, we don't even need to do that. We can check that automatically by just checking for this. So, let's see. Bottom right array exit result. Right now it's null. And instead of having that there, then we'll just do this. It's not for me, by the way, if you hear the phone ringing. Not me! Someone else pick up, please. Let's see, check for collide array. Yeah, okay, so we do that check. And if it was good, yeah, we need to do 2 of these then here. So we can just copy this here. Check for exit point. Exity. Exit. Check for exit point. And we can actually get rid of this because that's going to be controlled in the loop anyway. So we can get rid of this, and all of this, and that, and that. Alright, let's bring this all in. Let's make it look nicer. Check for exit point. Okay, so if I'll do this in reverse. Distance is not 0. Then break. We're done. So we don't need that one anymore. We have a 0 distance result. The result is what we're standing on. Now I need to check the reverse, blah, blah, blah. So if, I guess at this point, We don't need any of that, actually. So we do break out of here. Yeah. So we got our result, and so we can now check this result after the fact. Check to see if the ray results will be valid. And it's easy. If it has an exit point, it's valid. And so we get rid of this. We don't need that. That's what we transferred to above. So where this comes into play is only results after the exit point are valid. So if valid distance start, let's see, we need this dot distance must be greater than our valid start. So actually then if it's less than or equal to, continue. This result is in the invalid range. So it has to exceed this. Actually, can kind of do this backwards. I don't know if this actually... No, I think we can't avoid that, can we? So... if this is greater than this, but that means that they're equal. No, they're... yeah. This is great only if this is greater than. Yeah, we'd have to do we'd have to do the equals anyway. I was thinking maybe I could eliminate the equals there, but I don't think so. So if this is less than or equal to this, yeah, then it's invalid. We continue on to the next result until we get a hit here. And then so only stuff here will count. That should do. Because this will omit the collision with the 4 itself automatically. In fact, it actually probably don't even need this, because ourselves are going to be at the invalid distance, I guess. Yeah, we'll leave it. We'll leave it. We'll leave it. I'm not going to screw with it. If we can optimize it later, we can, but this may still serve an important purpose. Yeah. Okay, so if it's not after the valid point, don't consider it, and then everything after that is fair game. Okay, so new correction, move distances. Okay, yeah, and by this process we'll be getting the lowest amount of movement. Okay, here we go. We want to see if this works or not. So I'm gonna blow up right in my face. Oh, look it, we got a ray. We got a ray. Okay, so what we need to do, we need to go, I think, over here. So let's get out of the pit here, and we'll look here. Okay, he don't seem to give a shit. He just plows right through it. Is it firing from the right spot? It looks it. And it is shooting from that spot back to the spot it started, so that's good. Okay, here it should have hit something though. So why didn't it like that? Alright, let's put a breakpoint here. We will close this. That's top right. Not bottom right, right? Right. Making sure that they're all the correct ones here. Oh yeah, no, this is working correctly. I think. Because this here... do we want to detect that or not? It's a wall though, right? Did I just do something for nothing again? It is working correctly because we're still inside the thing here. We haven't left our collider because we're walking straight on it. So yeah, it's detecting the collider and saying, hey, you never broke away from it. So that this thing here is not a valid collision, right? It is working as it is coded. It's just not working as intended. And I'm trying to think, why are we doing this in the first place now? Okay, so the reason we don't want to do this normally, I believe, is because if you have... Yeah. So if you have something like this, and your dude's walking up, this will get hit by a ray as you're walking up. And you don't want this to be like, hey, we hit something, and then stop, like here, and be like, why can't I move? There's nothing in my way. Why can't I move? Because this thing's down here. And you may not be able to see this collider. You know, it may not be graphically represented as a top layer or whatever. That's what we're trying to avoid. But we've also destroyed... the ability... That's a horrible player, but you get the idea. But we've also destroyed the ability to see this. Because this ray is gonna fire, and it's gonna hit... Well, I'm gonna say it goes even farther than that. It's gonna go here, but it's like, oh, well, we haven't left. So say the thing goes all the way this way. We haven't left our thing here. We haven't left our original floor. So this thing is a invalid wall. It's the same logic. We're saying, hey, if we leave, only if we leave this, will we detect this. But that also, nullifies this ability to see this here. So, how do we check for that? We know this one, we don't want this one either. We're inside the floor. We did not leave the floor and go out here. Therefore, this thing is invalid. Only if this thing was out here and we had left the confines here would this be good. That's basically what we're saying here. We only want to hit this if it's outside. It makes sense, because you're already in the floor, you don't want to hit something else. But then how do we handle this? Now, in slopes that are part of the same shape are automatically handled by the points. So that's not a concern, it's only intersecting new shapes that are the concern here. In both cases, this would be considered a wall. Wouldn't be considered a floor. This would also be considered a wall. So there's no difference there. What can we do to figure out the difference here? That's really the big thing. What is there different about this scenario than this scenario? Other than the fact that it's flat here. Yeah, but you know, even so. Here's another problem. Yeah, this is also a problem. What if there's one here? It's also going to admit that. Actually, let's make it a little smaller because we do know that obviously there's something up here that we could possibly catch something on. But let's say that it's like this. We got 3 overlapping shapes. We do not want this one. This is bad. But we do technically want this one. Sort of. Because it's going along the... It's going along the line here. Now we'll never see... Let's see. So based on this, it'll be around here. So this ray is going to end here, this ray is going to end here, because we've got this kind of shape here. Roughly. I mean, they're a little off, but you get the idea. So here's the thing. We do want to see this as something that we need to accept. How do we do that? This ray is not going to hit it, and neither will this ray or this ray. They won't hit it. All 3 of these are just out of the question. They don't even detect it. And we are eventually going to have this ray, but again, in this situation, it's not useful. So how do we detect this thing actually as a wall? But we don't want to detect it underground anyway. But we do want to detect it from the side. So more to the point, I guess. Yeah, this exactly. How do we do this? I think I know what might have to happen. But I'm not 100% sure. What I'm thinking is that in this case, and I'll make a new example. I'm going to use a few new colors here so that we can keep everything in order. We're moving along this line, right? And we want this intersection to play out correctly. So we shoot a ray here and here and roughly here. So this ends up being our new line. It's a little off, but you get the idea. So we're looking to, if unabated, end up here. But what we really want is to end up here, which means that our true endpoint would probably be like down here or something. That'd be a little hard to see against the blue. But okay, so given that, this sure as hell is not going to see it because it's underground. In fact, the only reason to have this one, I believe, is if you're headed downward and you need to see something. in your way. If you find a wall here, you have to stop. I think that makes sense. Or, again, if you leave the ground and you need to detect a new wall outside of the ground's bounds, that would also be a case that you need this. But here is a different story. Here is a different kind of wall that you'll never reach with the center point, but you would reach with your extremities. So if you did end up moving to this position here, then yeah, you'd be in the wall, and that's not right. And that's no good, to be on topic, for the playlist. And that's no good. Don't let strangers touch you. To what Sonic says. Alright, so what if, for the heck of it, we artificially extend this ray so that it would eventually reach this? In fact, let's say that it extends up to the point where this would be even. Because we're simulating the... I guess not quite even. Yeah, so it's kind of like this. It's even enough, I guess. So it would simulate the end point of the... It would simulate this edge here, in order to detect intersecting things here. So, you know, the dumb math that I thought I didn't need when I did when I was sick and I had sick brain and I went off on this huge tangent that I didn't think I need. I might need it here. And I think what it did is it found the distance from here to here. And that's the distance that we need to augment this ray by in order to add this distance to the end here in order to reach the edge, I think. So maybe that wasn't for nothing anyway. Maybe we can use that. That's the only solution I see here. It's just augmenting this. So we would only normally respect up to here, I guess. But if we do happen to find something here, then we need to push it back, right? So anything from this range to this range, if nothing else has been found to be an issue, then we have to decrease our movement length by what we found here. Makes sense. So we'll have like two zones. I mean, it'll be one ray, obviously, and then we can just segment it into anything past the normal point is extraneous crap. So we'll check this range first here, because that'll overrule anything else. So we bump back our distance from there. Then we check... Maybe we might need two rays, actually. Might need two rays. Well, not necessarily. I'm thinking we have to check this, and then say if we determine that we have to sit back here. This is our new center point, right? Then we need to check this extra distance again up to this point instead. It actually decreases that. But we could do that after the fact mathematically, I guess. Because we could certainly just say, okay, then we shoot a ray from here to here. From here to here. That's fine. But it's an extra ray? Does firing a ray probably, yeah, firing array would be more expensive for CPU than it would be to just adjust our ranges here. Because we're going to do this in order from closest to farthest, right? So we shoot the whole ray. Shoot the whole damn thing all the way up to the end. That's a horrible arrowhead. Shoot all the way to the end. We first check this range here. And we say, starting from here, we're going to look at all the results going toward this point. And if they're at this point or less, that's the first check. Once we have exceeded this point, we look to say, hey, did our destination point get moved? Like, did we determine that we're only going to move this far for whatever reason? Cool. Okay, so our second zone is now going to start right after this. So it has to be greater than our new point here. The new point, NP, plus the length that we've discovered from here to here. And then, so this is our new edge point that we would get here. I think that makes sense. And so we're only treating the distances different here. Not doing anything else that's different or interesting. We're just... And then anything beyond that point, beyond our new max point, because we could get some stuff out here, because the ray was cast all the way, but we just ignore it. So once we reach a result that's beyond this point, then we just... nothing. We just bounce out and ignore it, because we've now shrunk our field of detection. I think all that makes sense. I hope I'm not talking BS. Alright, so where's that code that I didn't think I needed? That apparently I need. Did I put it in here? I hope I didn't erase it. Let's see. No, that's corner magnitude correction. Yeah, but yeah, we didn't need this. We didn't need to know this. Oh my god. Well, apparently we might have to. That's what we were looking for last time, right? I'm pretty sure, because we were doing basically this. We said, well, how far do we need to go down in order? We know our direction that we're going out in, so we do the direction backwards. And where do we need to fire from? Down here. Oh, that's a little different, though, right? That's a little different. I think we wanted to get the... What was our goal? Calculate the magnitude between the corner of the collision box to the vertical center. No, okay, that is what we want. Now the magnitude is this. That's the magnitude. I don't know how far away from it is. I think that's it then. Correction magnitude. Yeah, we do the a squared plus b squared equals c squared shit. Yeah, because we know what this is. That's a, that's b, and now we need c. Yeah, okay, I think that's exactly what we're looking for. Hooray, it wasn't useless! Holy crap, it wasn't useless! Oh man, this is gonna be a real pain in the ass though. Okay, this is gonna have to be before all of this. Well, this gotta go right to the front. In fact, we probably need to do this before everything else. So, let's put that up here. Oh, it needs a walk direction. Okay. Nope. Then, nope, apparently not. So, where's our walk direction? Determine walk direction, right? No? Oh, our walk direction's right here. Alright. If that's all we need, we'll put it here. It looks like it's happy. Cool. Then we can now use this. Oh man, it's gonna be a pain in the ass. That's gonna be a big pain in the ass. This is actually working correctly though, so I think we're all done with this. We can close that up and box that away. I think we're all good on that front. So we don't have to worry about the corner raise. We don't have to worry about the wall check. So we'll close that. So this is we're gonna be going back to the center ray here. And we're going to be doing this change in behavior. So this is going to be a little bit of a nutty thing, but let's see. Cast walk ray. We might want to do this on the ceiling as well. We'll probably have to also do it on the ceiling in order to catch any weirdness. But let's do it on the floor first. If we can do it on the floor, we can then replicate it for the ceiling. This is going good so far, though. We're doing good stuff here. Okay, so we need to augment our walk movement distance with this. So I'm gonna change this to purple? No. Is there purple? There's no purple. Cyan, blue, clear, gray, green, gray. 2 grays? Wait, what? Oh, clear. Red. Clear is gray for whatever reason. Fucking dyslexic. Magenta, white, yellow. Magenta, fine. Let's see. Yeah. Wall check extension. Extension? I don't know. Whatever, it's a comment. It doesn't have to be spelled correctly. There's no spell check here. There's no gods, no masters. Only math. Only math. We want to do this one actually before, so it will appear underneath the others here. And since it will be an extension, we should be able to see that. And then plus the corner, yeah, plus the corner correction magnitude. Okay, so we got to do a couple things here. Here's where we're going to start checking the results, right? So we need to have initial range end equals move distance. So if we do detect something before we get to the end of this range, let's see. In extended range check, it's false. Yeah, so if we do exceed this, then we need to go to the next one. And so we need to float extended range end. And that's going to equal 0 for now, I guess. Or no, you know what? You know what? We can give it a default value, that's fine. It's the full ray length. Not sure 100% we need that one. I'll leave it there for now. So, okay, we're gonna ignore those in both cases. So we can do if ray distance is less than or equal to the initial range. We're gonna do this shit. Yes. That's our initial behavior, right? So I'm trying to think of what we want to do here. You know, we might not have to do that. Let's undo that. I'm really only concerned with the result here, so hear me out a second. I think so we're looking, if we only hit our initial range, that's cool. I think. Right? I think we might be able to simplify this. We might be able to simplify this a lot. What if we just cast the whole damn thing as it is? We take whatever we find, and then we just subtract the magnitude from it. So whether we hit it here, or here, or here, we subtract the magnitude, and we ended up with this point. And that's as far as you can. Yeah, okay. So I'm thinking, let's simplify this. I don't need any of this shit. So here, the walk move distance is going to be the distance minus that correction value. Because we're automatically shooting at least to the end of this, even if we're not doing anything. And so we'll get snapped back out if there's anything inside, even. Which actually might be a good correction method. Okay, and that makes it really easy to port this to the head piece. Because all we're doing is just adding this plus on the magnitude and then subtracting it off of our thing. So, ceiling cast. Ceiling move distance plus that. Say it was red, right? Plus that. And then we get down here, this is minus it. That's it, I think. That should be it. And we'll see if this is correct. I think that's really all we need. Before I get ahead of myself, just check here. Ceiling move distance. Okay, and then yeah, it checks these separately. And it sees which one is lesser. And then it sets move distance to that. Okay. That's what I was worried about, that move distance wasn't being set now. But I think we're good. We might be all set. Oh boy. Alright, so this behavior shouldn't change. It should be all the same. It's this down here that needs to change. Oh boy, what are we gonna get? No, get done fucked is what happened. What the hell? Oh, we weren't using the red, we were using magenta. But yeah, you do see it. You do see the extension here. Which doesn't seem to quite represent. See, it's overlapped, so it's really hard to see here. How do we make this a little better? What if then this draw ray here, give it a little give it a starting point so we can see where the damn thing was fired from. Or you know what? Back up. There's actually a more immediate solution to this. We can just draw this second target. It'll be on top of it, and that's fine. That's ceiling. I need to do the wall one. Oh, right, and the ceiling one here, magenta. Right, and so this will be drawn above. That will make sure we can see it at least. Now we can figure out what else. Out of the hole, I'll get him over here. In fact, actually, before I start this, just drag him over here. Where is it? Oops, one, that's this will fall down. Why is this all the way out here now? Doesn't seem right, does it? Alright, for the bottom one, let's turn off the future step here. Just get a better idea of what we're dealing with. And then we also want, so we don't need the ceiling ray right now. Fix that once this is ready. We do want to go to the wall check. We want to undo the debug here. Compensate for services, or narrated. Bottom right. So I'm just gonna make that invisible for now. And we'll see what we can get here. Okay, the red, we're not concerned about the red. The magenta doesn't look right though. Magenta should only be searching like right here. So our calculation might be wrong on how much of a compensation this is. Yeah, it's shooting from the right point. That's right, because it goes from here to here and here, and that's where it ends up. But it should be reaching the end here, but it's doing double that for some reason. Just for the heck of it. Go back up. Let's only... Let's cut this value in half. Just out of curiosity if that's really what's going on. Why don't I like that? Don't like the value. Oh. Inverted. Alright, let's see if adding that half helps or not. It's not right. So the calculation itself has to be wrong in some measure here. Otherwise it would have lined up. It should line up at the end. Is it showing 2? Because it does 2, right? Yeah, I think it's because of these 2 here. Right, and it's shooting... Yeah, it should from here to here. And from here to here. So the extension is from this point to this point, but it's wrong. See, here's the deal. We can't just say the magnitude from here to here, because if you start to rotate it, it'll end up like this. You need to reach all the way to the end for this to work. So there's something wrong in the results here. So we're transforming vector from local to world. Point. Oh, direction. That's probably part of the problem here. Let's see if that helps. Nope. In fact, it looks like the same result. Does it usually have a built-in thing that lets you go up ramps and stuff? It has its own physics engine, but the results that can be obtained with that are not satisfactory to me. You won't get the old school platforming precision and control that you would from the old games if you use the stock physics engine. And it also won't look right in 3D games. For 3D games, arguably it would work better, but not for 2D games, especially not. So I'm doing that on my own. Yeah, because like, what'll happen in that case, like say if you have a box, and like this is your character, if you end up going up a slope, you're gonna, oh, that's bad. You're gonna end up going up that slope like this. And so that if you have a character here, you know, well then your character is standing like this, off the ground in midair, like, it's a crappy character, but you get the idea. That's one of the problems with this. So he's standing on his toes on this floor, and it looks stupid because why is he standing like this? Or really, what you should be doing is having him stand like this. Get every pixel here. You should have him stand like this. The Unity won't allow that because now this solid object is protruding into another solid object, so it will pop you out. You know, if he comes and lands like this, he's going to get popped out. That's if you use the stock physics stuff. So to avoid that, we have to do all our manual calculations and stuff. And so when he walks, he'll walk up like this, and that's how all the 2D games do it back in the day, because this looks stupid. So you need to make sure that they're focused on that center point. You could rotate it, but if you don't rotate it before it hits here, you're not going to reach that. So sure, like if you did rotate it, just for the heck of it. Yeah. So okay, you rotate it, and sure that works here. But then what happens if you have this? Okay, you could land flat here. Well, what if you land here? Then what? How does this work? Do you angle between them? That would look weird too. And beyond that, if you don't angle this ahead of time, before it decides to try to collide you with something, you're going to get that orientation. So you can angle it this way, expecting to hit this, but if you hit this, you're going to end up like this. Whatever you hit is going to be whatever orientation you are while you're moving. You can't change orientation once you've moved. Or after you've moved, you can only do that. Unity won't handle that rotation. If you tell Unity to control rotation while doing physics, it will like just bounce and rotate you, and you'd be flying. You'd be like a box, just tumbling everywhere. You wouldn't be able to walk. You'd just be tumbling and fumbling all over the place. It would treat you as a ragdoll object in that case, essentially. Yeah, no problem. Yeah, it's a little goofy. Like, it's good for things like, oh, I want a box or a particle or something to fall down a hill or whatever. That's fine, but once you get to like actual characters, that's where it gets complicated, where it just doesn't look right. It doesn't look nice at all. Weird and whack. It feels weird. Yeah, it's all sorts of bad. So instead, I'm pulling my teeth for the next few months trying to figure this out. And realistically, there's not much that they could do to help that. I mean, each game potentially might feel and act differently with certain objects. So there's not really a all-in-one solution they can give you. It wouldn't be customizable at the very least, and so you run into all sorts of issues with that. There's no one-size-fits-all solution. The way that I'm doing it here might not necessarily be good for all types of 2D platformers. So on. I'm taking more a page from like the Mario lineage, studying those ones and seeing what they do. Mario and Mega Man are pretty similar in how they act. I mean, obviously they have momentum. Mario has momentum and Mega Man doesn't, but the way that they interact with the world and the objects around them are actually pretty much identical. And then, so I'm taking a page from the greats. It just kind of takes me off that Unity sells their stuff as if it just works. Yeah, well, yes and no. There's a lot that they do for you that just works. There's a lot of stuff that just works, but the rest is on you. They give you the platform to build the house on, but they're not going to build the house for you. You got the plot of land, they bulldozed it, they made it all even, they put in the basement, but now you've got to build the house on top of that. So they do a lot of stuff. Yeah, it's just not accurate to say that. Not in my opinion. There's a lot of stuff it does do, which you have to give it credit for, but there's also a lot of shit that it doesn't do. You think of Unity as the landscaping company, and they come in and they get everything ready for the carpenters to come in and build the house. But if you're not a carpenter, you're not going to be able to build that house. They help you. They help get you halfway there, but they can't do everything for you in that regard. It's too granular. At some level, you're going to have to start making your own decisions on how things need to act and behave, and there's no way that they can account for the thousands of different ways that can go. So they give you the tool set to build the house, but that's it. You gotta actually put it together, and it'd be the best way to sum that up. And already that's a huge help. But there's not much else they can do beyond that. They've done all they can, and then from there it's up to you. Alright, so we're trying to figure out why the hell this shit don't work. Alright, let's take a look at this. I think we've done this, but we didn't actually test it. The idea here, okay, transformer direction, negative walker. Local distance, AV, arc collider, bond size, yeah, divided by 2. Local tri-point C. So here, pretend that this is straight. We're trying to find different colors. Different colors is always good, right? Okay, we're trying to find how long is this thing here. We know what A is. We know what B is. We got our direction. We know our walking direction is this. We're basically counting back from the corner, back to the center here. We might be running out of time here. Oh, here we go. I love this song. I'll turn this shit up. One of my favorite modern Sonic songs. I don't know why, it's just so good. Give that shit to me. Give me it. That's right, baby. I got the master plan right here. Local tri-point, let's see. Yeah, Sonic's got great music. All throughout. Really does. Local tri-point, our offset X. Local distance between A, B. Oh no. Alright, there's a bunch of shit going on here. Let's see. Night travel, let's start now. Oh, okay. Let's see this step by step. What is it? Transfer the direction. So the reason we need to transform the direction is if we're looking this way and our walk direction is this way, just for whatever reason, some dumb reason that we're rotating going that way. We need to take that and make sure that if we port this direction automatically from here, it's going to look like this. It's stupid. That's not what we want. We want how much it is from the side here. So that's right. Transform our direction so that it lines up with normal straight up and down space. Thanks to you. Local distance A to B is the size divided by 2. That's fine. So that's the distance from here to here. So it's this. So we know that. We know AB. Okay. Try point C. So we need to find the point of C down here. What do we know? We know our offset. X. Our offset X. saying, okay, so what we're saying is if this happens to be offset from, say this is where it was originally, and then the box would have been here. If our offset is like negative, like 1.0, it would end up over here. What you're saying. Or what I was saying, I guess. So that's fine. So our we know that C is going to be straight down from A. So its X is going to be the offset. That's fine. And its Y is going to be the distance AB divided by the angle X times the angle Y. I think I see why I was doing this, but I'm not sure that's actually correct. And then it goes to a world point. And then we do the Pythagorean theorem on world points. Because we need BC. We don't have BC. No, this is right here. Alright, let's see. Why are we doing this? Taking a distance AB. So let's say, I don't know, it's 0.5, right? Times travel X. Divide by X. I don't know if it makes any difference. I think it would. I wonder if we can do that first. Let's use our ratio. But I don't think this helps. That helps. It's saying we take the direction and we apply the direction to this distance, but that's only going to get us like here. It's only going to give us this curve. We're going to end up here, but that's not right. It's not right at all. It'd be cool if we could get AC. Reference. Get AC. Okay. We're trying to get the point here. We know that the X, CX is going to be AX, because they're in the same vertical location. We only need to know what Y is. But in this case, Y is more helpful. An oval still won't be right, because if you're an oval and then you try to land on a hard edge, you're gonna look like that. Your dude's gonna be standing like this, like with his foot inside the thing, and it's still gonna look stupid. And there's your dude. That's quick and dirty. Even at the oval, you're gonna have weird shit like that. Trust me, if there was an automatic way to do it, I'd be all up on it. But it's not gonna give me the results that I need. We know what the X is, but we don't know the Y. Oh, I know why we're doing this. Okay, so the idea here is that the direction here. So the walk direction, it's got an X and a Y, right? And under normal, non-rotated conditions, this is a ratio. So if the X is 1, and the Y is 0.5, then you get this angle. So basically 1 to the left and 1 down, but since you have to consider you don't have 0.5 pixels, so this becomes 2, 1. It's a ratio of 2, 1, and then you get this direction. So if we say, all right, that's the direction, then we can magnify that and get all the way to the bottom. So if we say the X, you have to go this far in X. So that's AB times 1. Get you this long here. Let's say divided by 1, right? Because you could have a you could have a 0.1 here or something. It doesn't have to be that way. But you get the idea that it's a ratio. So if AB is 1, well then AB divided by 2 is your Y. It's just living word. Yeah. So if this is AB to the left, then this is half AB to down. And that's the idea here. So, alright, let's think about this again. So, in fact, actually, go this way. But I think order operations would have taken care of this. That's why I didn't have any practice on here. But this might be the wrong way of thinking about it. So, okay, so let's say that distance. Let's say that distance is 5, then we're going to divide 5 by 1. Obviously, we're going to get 5. And this is 0.5, right? So 5 times 0.5. You get 2.5. Good. Did that right. 5 divided by 0.5. 2.5. No, that's right. So if we traveled 5 to the left, then we do 2.5 down. If it was 1x, 0.5 y, which would make our x whatever it was, and then the y would be that. Okay, so the reason I think I did this step is say that, say this is 5, and then divided by 0.5, right? It's 10 times 1. I don't know if that works either. It might just be this. It might just be that. I think I was going too deep with it. It might just be that. Oh man, this track is great. This one comes off Mania. Holy shit, is it hype. Yeah, this actually might have fixed it. About to find out. Hella no. Not even close. Oh, he did this? Oh, nice. I might have passed it up because it might have been a spoiler for me at the point that he did it. I'll have to check that out. Oh man, I can't imagine the Gameto version of this. Holy shit. Alright, this is still bumpus. so then we're getting A, B, A, C. I don't know if this is wrong or not. I'm wondering if the error might be somewhere else. Is this thing normalized? Ever? It doesn't look like it. But would it be normalized from all this stuff? It is normalized. We can check that too as it comes in. Oh, it's not happy. Why is it not happy? Oh, I'm not moving. There we go. It caught it. Our walk direction is 1, 0. Okay. And so in this case, it's going to be -1. -1, 0. Oh, and there's our time's up. I'm gonna go just a little longer to see if I can figure this out. I might have an idea what's going on. It's a negative, right? So we go to the next step, and this should be a negative. Oh, what happened? Huh? What did? Oh, oops! I did the one. I didn't keep up. Okay. Our travel becomes -1, 0. That's fine. But we're orientated upright, so of course what we're going to get is going to be negative what we put in. So that's fine. Alright, let's see. So this is going to be a distance that's going to be 0. It's going to end up being 0, and that's fine. Because the y is already 0. That's okay. But then it should come up with... Let's see. Let's see what we get. I want to get down this far. This would be 0, 0. Right. That's correct. That's -4, 4.9. Okay. Then top center is negative 4.2. Yeah, and its top center is -4.2, and it's like 5 tall. 5 point whatever. That's fine. So the distance from here to our collider world point, which this one, number 2, is, yeah, so this should be 0.2 distance, I believe, or 0.25. -4.2, 5.4 tall. -4. Oh, it might be truncated. Yeah. So it's -4.22. So then this says -2.5, but I think it's truncating. It's truncating that. So that's fine. That's reasonable. So we need to know the distance from A, from top point to roll. 5.4, 4.9. So that's 5.5. 0.5. Okay. And this looks okay. So A squared plus B squared equals C squared, right? So yeah, A squared plus B squared, take the square root of that, and then you get this is C squared. And that should be right. None of this looks wrong. In fact, the points coming out of here look pretty legit. Yeah, points here look pretty legit. You see, this world tri-point C has the same x's the A point does. And that's right, and it is lower than A, so that's also right. Alright, it might be better to redo this test. Honestly. Where'd my paper go? I'm gonna go over here. This is actually gonna give us a non-flat result. So our walk direction our walk direction is that 0.9 and okay. Yeah. Okay, this is why I did that before. Because this is not necessarily going to be one, so you can't trust that the other one's going to be right there. So so we've got 0.9 to negative 0.4. In fact, this will be negative 0.9, and once we invert it, it comes in. Okay, negative 0.9, 0.4. Size is 1 divided by 2. So let's actually do this here. So this is right. This is 0.5. Dumbass with 0. So this is right from here to here. That's 0.5. And our direction was negative 0.9 by 0.4. So, let's see, we need to say that do we first need to get this to be a 1 something? Do we not? Alright, let's do what we did originally. Let's take the 0.5 and divide it by negative 0.9. And what do we do? That's what we did first, I think. Or what I thought I should do first. 0.5 divided by 1.9. I don't like it. Hold on. Serious? Alright, hold on. 0.5 divided by 0.9 negative 1. Oh, there we go. Okay, I don't know what the hell that was. That looks pretty okay. That looks about right. It's gonna go left. Is that right now? Does that compensate for this here? I don't know if that doesn't look great. Well, no, I'm not using Unity's built-in stuff at all. I'm completely bypassing it, doing my own. So I'm not trying to rein in the results that Unity gives me. I'm just not letting Unity do that at all. It's just doing its own thing, completely ignoring the built-in system. Yeah. Yeah, that was one option to kind of correct what Unity does, but it quickly decided that no, that's not going to work. It's really hard to correct for that kind of thing. This should be more simple than I'm making it out to be, I think. And I think it's not unreasonable to think that this value is how long this might end up being in order to reach this here, but I'm not sure that's totally correct. Okay, just for dumb logic's sake, I'm gonna try it. This actually works. I'm not freak out. What I did this, right? This is so dumb, but if this works, I'm gonna freak the hell out. No, not even close. Okay. Yeah, that's what I had before, right? We know this doesn't work, right? It's just not right. See, what I'm thinking here is that I'm probably overthinking this or something. So you got the x and y as like a ratio, right? So if you say that this like is in place of this, and you can get how far down it goes, you know what I mean? Just hold on. Hold on, what about this? It's a ratio, right? It's treated as a ratio. X divided by 1. And then times the x travel distance. Now, bounding box doesn't work in this case because it doesn't handle rotation. Okay, what do we got here? Where's that magenta arrow? Where'd it go? bet you give us 0.9 divided by, that gives us negative 2. Oh. Maybe we gotta do that backwards. So that's gonna be times 0.5. That's gonna give it that, and that's not right. That's not even close to right. Let's do yeah, that looks a little better. Times 0.5. That looks a lot better. We might have it just reversed. Damn it! Son of a bitch. Why is it still fucked up? What do we actually get here? I want to know. What's your final answer? Survey says... Can you stop here? Oh, stop here. 0.5 divided by 7. What about? Think of it wrong again. Yeah, alright, how about this? It's just a multiply, right? Divided by 0.9. I think it's just the same thing. Yeah, that good music. I knew you'd like that one, that's why I put it on there. Yeah, so this is times the y divided by the x. I think that kind of just gives us what we already have. So let's see, just for the heck of it. Basically what we've been getting. We're just beating around the same damn bush over and over again. Alright, let's do this like legit real world. Hydro City is pure New Jack Swing. New Jack Swing? The music genre. Not familiar with it. Alright, let's do an actual real world example here. I don't know what you mean by winding number algorithm, but I'm not sure that we need to do that. I had a similar problem before that we solved in this way too. I wish Tim was here. Tim was the one that figured this shit out when we needed to do it. Because he's like, hey, wait a minute, like, the x and y is like a ratio, and you can step it backwards. So this whole thing ends up being a ratio. You know what your x is. You know where x has to be, because it's the same as c. That's 0.5. And you know the ratio of the direction, which is, I don't know, we're gonna make one up. So if we normalize, just to do this right here, or let's say, you know what, screw it. Let's say it's 1, 1. Our angle is 1, 1. Like, it'll never come in as 1, 1. It'll be normalized, but say the x and y is 1, 1. So that means, quite literally, we know that it's going to look like this. Alright? And this is our other end. And this is our other end. So A, B, and C. We know that CX is also AX, which should be 0. I mean, we know it's 0 because A is at 0. So it's 0 something, 0y. We know that our angle down is 1, 1. And we know that AB is 0.5. Right? So we can say that y is equal to 0.5. Or it'd be AY minus 0.5, right? Maybe that's where I got it wrong. That might be the problem here. So we need to know what A is in local space. Vector 2 local A. Local try point A. Yeah. I think that's the problem here. Because I don't think there's any reference here. So it's the offset X, and then our collision box dot size dot y divided by. So y minus that additional bit there. Because we're going down. It's this y, and we're going down from here. Because we know the x. And we've got the y from here, but it's y from here down. That might be where it's screwing up. Yeah, so it's the same x. We don't have to, actually we don't have to calculate that again. Just say this. Yeah, I'm not sure I understand what you mean with the winding, creating a circle and all that. But Like, we're not doing any collision stuff right now. We're just trying to figure out. Let's see. That might be okay. Oop. Oh, there it is. Yep. That was the problem the whole time. I just didn't minus it for May. Oh, thank God. Okay. Oh, thank God, that actually worked. Alright, that was the goof. Okay, and so now we just need to make it do something, but I think we're gonna call it here for now. Okay, that worked. Yep. I knew it would work. I just had to get the problem where I didn't do this. I needed to subtract it from AY. That was the problem. That's great. So that took 40 minutes to figure out? Yeah. Alright, that's what happens. That's what happens. I'm like, I'm sure I'm doing this right. I don't know what's wrong. That's what was wrong. Okay. Yeah, and then we do this all in local space so that it's, up and down, left and right. We know that. And that's the only way that we know that the AX and the CX are the same, because we get orientated in local space. It's not rotated there. And then we just bring it back to world space, do the Pythagorean theorem, and we got our distance. And that's it. So, okay. Alright, before we celebrate, though, let's pull them up here and make sure this looks right. Please, God. Please, for the love of God, please look right. It doesn't look exactly right. It doesn't look exactly right. It's close. I don't know. Oh, you know what? Okay, hold on, I think we have a slight thing to do here. I think? No, that shouldn't do that either. No, hold on. Yeah, I'm fumbling in my head now. So this lining up here is right. We were here. We only moved this far. But the total thing should be here. But the other one's off by some measure, which is not completely right. It's a little too far. Well, alright, I'll have to figure that out on my own time. We're already in overtime here, so I think we'll cut our loss for today. We at least got it right in one orientation, but we don't know what it is in the other orientation. So that's alright. The other thing we could do is we could do the Pythagorean theorem in local space, and then just scale it up. So I might try that. See if it works. Either way, I'll share what the solution is next time, and we'll do it from that perspective. So I got the retro consoles back and working. Hooray! And it works, and it looks really good. So we're gonna actually be able to resume Silent Hill 2 on Saturday. That'll be at 7 p.m. Eastern Standard Time. Then on Monday, we'll be back with Pocket Fighter EX. Staring at code. Yeah, pretty much. What was that? Is that a coffee cup? Is that Dan with a coffee cup? That's perfect. That's perfect. That's what it is most of the time. So we'll be back to Silent Hill 2 on Saturday. We can actually resume that now that the retro consoles are back. Thanks to RetroTink, which TLDR is really good. So check into that if you want to play your old consoles on modern TVs with HDMI. So that aside, Monday we'll be back with Pocket Fighter EX programming, and that'll also be at 7 p.m. Eastern Standard Time. And then next Thursday we'll be back again with this game, this project, the Retro Mansion project, and we'll be back with more platforming stuff. And I'll share what I did here. If I figure it out between now and then, I'll share what I did here, and then we'll know what happened. And that's pretty much it. So this stream is patron funded. keeps the lights on, keeps the software paid for, so that I can actually do this. We got top patrons. We got Zombie Killer, we got Corporal Chungus, Mike Cruz, Taryn Williams, AJ, and Bryce Nagalino. So extra super thank you to our top patrons. And if you too want to join the Scrub Army and help out, then you can go to the Patreon link down below. And we've got code samples stuff. We've got early builds of the projects that I work on stream. All sorts of good stuff. And we'll be adding more benefits as time goes on. I'm thinking of doing like a poll for the next game to stream after October is over. It's all the other spooky stuff that is still done. And then I've got some games that I want to play, but I'm not sure which one. So maybe you guys can help us decide that. And that's pretty much it. So scrub out. See you next time. Have a good one.